This is Jake Bazicki with an ACT Science data interpretation question. Now, this question is a very interesting question, and this passage actually as a whole is a very interesting passage in the sense that it's introducing a different kind of diagram than you're used to seeing. It's introduced something called a phase diagram. And this will happen every once in a while on the ACT Science test where they introduce some new diagram or some diagram that's not just a graph or a table. And it is important that if you don't understand what the diagram is telling you or how to read it, that you look back into the passage to understand it. If you look back into this passage, we're asked about this phase diagram. It explains that a phase diagram has lines, that the lines in a phase diagram represent the temperatures and pressures at which a material is changing from one phase to another. At a given temperature and pressure on either side of the line, the material will exist in a different phase. At those temperatures and pressures in the line, the material exists in both phases simultaneously. The phase diagram for an unknown material is shown in figure 1. So when we read this piece of information explains to us how to read this diagram. It's saying that these lines are places where a material is going from one phase to another. And if we're confused about what phase that is, we can just look at table 1 and see that at point A, we have a solid. So this is point B is also a solid. These two different solid phases. Point C has a liquid phase, and point D has a gas phase. So this line indicates the temperatures and pressures at which the material D is going from a gas to a liquid or a liquid to a gas, or this line indicates where the material is going from a liquid to a solid or a solid to a liquid. And then we're asked here which letter on which point on this diagram indicates where the material exists most likely as with parts solid, liquid, and gas. And we can see here that on the lines that the material exists in both phases. So right at this temperature and pressure, you'll have this material exist both as a solid and a gas. There'll be parts of each that haven't, you can think of it like at the boiling point for water. The water is boiling, so there is gas, trapped, evaporated water, but also the liquid that is still changing into the water. And this is what this line indicates, that same sort of phase change environment. So we're asked which point in this diagram is the material likely to be in all three phases. And so at the lines, we see that it goes from one phase to another, but it's only two phases. And so the area where it goes into all three phases is right here at point E, because we have solid changing into liquid, and solid changing into gas, but also gas changing into solid, and just gas changing into liquid, and liquid into both phases as well. All three of these different phases collide right here at point E. And that's the answer. And this is a hard question to answer if you don't understand how a phase diagram works. But like I said, if you ever aren't sure exactly how the diagram works, just go back into the text, because the text will and should explain it.